Hello and welcome to this video on how to specify a mimic model in the Mplus software. My name is Geiser. I'm an instructor and statistical consultant with QuantFish. So first of all, what is a mimic model? I have a separate video on this topic where I discuss mimic models in a little bit more detail that you can check out as well, but just real quick, as a reminder, a mimic model is a confirmatory factor analysis model, like for example this one here with two factors, where you have covariates of the factors. So in this case I have three x variables, three covariates or predictors, on which my two factors f1 and f2 are regressed. So it's basically a structural equation model where the predictor variables are observed variables and the endogenous or dependent variables are latent variables. So it's sort of like a hybrid model between an observed regression analysis with multiple outcomes and a structural equation model where you have latent factors. So how do you specify such a mimic model in the Mplus software? Let's go and take a look and see how that works. Here you can see my Mplus syntax and output file for a mimic model example. In this case, I'm using an example where the factors have only two indicators. So you can see here f1 has indicators y1 and y2. F2 has indicators y3 and y4, and then both f1 and f2 are regressed on two covariates, two exogenous variables, x1 and x2. So those are manifest variables. For example, gender and age could be covariates that we want to examine, where we want to look at whether they have an influence on the factors or whether the factors can be predicted by those covariates. And so we're doing this in a latent regression analysis where f1 and f2 are both regressed on x1 and x2 in Mplus. And then here under output, I'm requesting the standardized solution so that we can also take a look at standardized parameter estimates. Now let's take a look at the Mplus output and see what Mplus gives us for a mimic model, what kind of estimates. And so here you can see, first of all, the sample size here was 259 cases. And we have continuous dependent variables y1 through y4. Those are the indicators of the two latent factors f1 and f2. We have two observed independent variables or exogenous variables x1 and x2. Those are our covariates or predictors of the two factors. And then we have our two continuous latent variables that are endogenous in this model that are predicted by x1 and x2. Next, we can see that the model estimation terminated normally. There were no convergence problems or improper solution problems here. In this analysis, we can see that this model fit the data very well. The chi-square value is 4.225 with 5 degrees of freedom, and the p-value is 0.5176. So this is a pretty high p-value, indicating that the model does not have to be rejected at the 0.05 level. Other fit statistics here also look good. The RMSEA is 0, CFI and TLI are 1.0, and the standardized root mean square residual is also very small with a value of 0.024. Next are the unstandardized parameter estimates, and you can see, first of all, we get the loadings of the variables on the factors. The first loading is always fixed by default in Mplus so that we can scale the latent variable appropriately. The second factor loading is estimated. And then next we get our unstandardized regression coefficients for the regressions of the factors on the covariates. F1 regressed on X1 has a coefficient of 0.038, so that's our path coefficient or B coefficient in the regression analysis. You can see this coefficient has a standard error of 0.05, so this is a large standard error relative to the estimate, so therefore the test statistic here, which is a z-statistic, is small and the associated p-value is greater than 0.05, indicating that this coefficient is not statistically significant. It's not significantly different from 0, and so this means that there's not a significant association here between the factor f1 and x1. Likewise, we have a coefficient for x2, and that coefficient is larger, 0.214, with a standard error of 0.06. So then this yields a z-statistic that is more substantial at 3.57, and that p-value is very small. So the second covariate is significantly associated with factor f1, whereas the first covariate x1 is not. For the factor f2, both covariates have a significant coefficient. So you can see these are larger, and also you can see here that the p-values are very small. So both x1 and x2 are associated with f2. Another thing that we get in Mplus is the residual association between the two factors, and that's automatically included in the model by Mplus. So when f1 and f2 are endogenous variables, dependent variables like in this case, then we can only examine the residual association between them in the model. And so that's the association between the two error terms or residual terms for f2 and f1, meaning whether f1 and f2 are associated after accounting for x1 and x2. And so you can see here that there is an association of 0.164. This is a covariance because here this is the unstandardized solution. So the covariance between f1 and f2 is 0.164, and it is statistically significant. So after accounting for x1 and x2, there's still an association between those two factors. Next, we can take a look at the standardized solution. STDYX is the completely standardized solution where both the observed and latent variables are standardized. And so here you can see the factor loadings, which tell us a little bit more than the unstandardized loadings. So here we can see that those standardized loadings for F1 are not very strong. So those measurements may not be so reliable, having a lot of error variance, or they may be heterogeneous. And so you can see those loadings are relatively modest. The ones on F2 are somewhat higher at 0.71 and 0.77, so those are somewhat stronger loadings. And then we also get the standardized path coefficients for the regressions of the factors on the covariates that you can see here. And so those can be interpreted in terms of standard deviation units, which may be a little bit easier when the covariates and or the factors have an arbitrary metric that is not easily understood. And then also the standardized solution gives us the residual correlation between F1 and F2, which is more interpretable than the residual covariance. So you can now see that the factors are fairly strongly correlated after partialing out x1 and x2. So the partial correlation of the factors after accounting for x1 and x2 is almost 0.5 at 0.479. So that's a pretty strong association between those factors after accounting for x1 and x2. And then at the very end, we also obtain reliabilities for the observed variables. Those are the R-squared values, and you can see that they're pretty small, especially for y1 and y2. So this indicates that those measures are not super reliable measures of those factors, that there's a lot of error variance or specific variance in those indicators that is not accounted for by their factors. And then also we get a latent variable R-squared for the two factors because they are dependent variables. And we can see here that 13.5% of the variance in F1 is accounted for by x1 and x2, and 33.5% of the variance in F2 is accounted for by x1 and x2. So this is the result of this latent regression model with observed covariates, and that's called a mimic model. I hope you found this video useful to learn how to specify mimic models in Mplus. If you did, please subscribe to this channel. Also, check out our description for additional resources, including workshops that we offer through QuantFish, and I'll see you next time.